This is a talk that I hosted Sam Altman last summer. Like, AI is a thing, and I guess I wanted to try and convince you that it's an actual thing, not a pretend thing, because it's very easy to just think this is just another cycle of hype. I guess my PhD's in machine learning, so I guess I started doing AI in '99. I guess I started mining Bitcoin in 2010. I tend to get into things like 10 years before they actually do anything useful. I'm trying to convince you that AI has actually done something useful in 2023. I was co-author on a paper got an ACL award showing how rubbish ChatGPT 3 was. And then ChatGPT 4 came out and I was like, oh dear, something's changed. So, we're now sort of used to systems that might be able to contribute to helping us do stuff, write stuff, answer questions, maybe replace a search engine. But honestly, quite impressive, maybe pretend slightly contrived tasks, but can pass exams. Wrong way. And that has obviously affected at least one company in terms of valuation, right? So ChatGPT from OpenAI, probably the most famous one, and went to hundreds of millions of users very, very quickly. So it's like a new sort of consumer web. And suddenly, Gen AI or generative AI investments have gone up dramatically, which is why I'm talking to you, because presumably some of you might get offered the opportunity to invest in AI. I should say my one exit is actually an AI company. Angel investment as an AI. My actual, as a founder, I guess I exited an AI company significantly, and my angel investment that has returned my other 16 investments so far was also an AI company, right? So that was a company that went from, I guess I invested at 8 million 2 years ago and exited at 180 million valuation in 24 months. So it is possible in this space at this time to find interesting things to put your money into. And the main thing I want you to take away here is just how quickly it changed, right? GPT-2 is like a toy, right? And you can just discard it and think it's irrelevant. But ChatGPT-4 is basically a tool, right? You can't use it for everything, but you can use it for quite a lot of stuff. And that only happened in 4 years. So the thing to take away from this talk is how quickly some of this stuff is changing, right? I think I was a little bit of a skeptic, and now I'm a bit more of a convert, even in the last few years. So at the moment, you're in this phase where, NVIDIA stock looks really high. What is going on? This can't possibly be worth it, right? It just got priced yesterday, higher than Apple. And you've got lots of people that have an interest in AI, and genuinely the AI community is completely split. There are some people who are like, this is an irrelevant innovation versus, it's just predicting the next word, versus a lot of people, maybe not the majority of the AI community, but a significant minority are like, no, this is actually some sort of intelligence. And so I guess the takeaway from the talk is supposed to be this is likely to change things quite quickly. And so I haven't put in a whole load of what my investment thesis is or what you should do, because I don't actually know. I think the main takeaway is I think it's going to change quite quickly. But if I tell you how I think things are going to change, then you can factor that into your own investment thesis. So here we've got a graph of the time or the date along the x-axis, and we've got a normalized compute compared to GPT-4. GPT-4 in my head is like the threshold moment. And on the annotations here go roughly the capability of the output, right? So preschool to elementary school to student level in 4 years. And the question is how quickly does it get to something that's more than a student level, right? At the moment, it's kind of got the capability of something that's got 2 to 3 years of training. So it's not a human expert. But it could well be quite quickly, right? How much of the work do you do that requires you to be a high-end expert? Not much, right? I don't know where we sit on there. I sit somewhere probably above high schooler, but not dramatically. for 90% of what I do. And this is an interesting chart. This is showing you how quickly it's taking to match human performance on certain types of tasks. Again, you could be highly critical. We could say whether it's really working or whether it's not working, but the point is the improvement is happening dramatically. So here we've got examples of image recognition, of comprehension, of question and answering, and how dramatically it can get up to human benchmark performance. The other thing that I think is the main takeaway is how wrong people are. So this is at trying to predict how fast and how good this stuff might be. So here is a prediction from 2022 about how well these models that we're building now would perform on maths. And so the grey Gaussian-shaped thing on the left-hand side is most people saying it's got no chance of passing maths tests. And then 1 year later, those are expert predictors. Those are people that are supposed to know what this. And then 1 year later, we've got this red star, which is the actual performance. So not only is it improving, it's improving faster than lots of people would anticipate. This is probably easiest to show in images. So on the left-hand side, 4 years of development, it goes from something incredibly pixelated to now auto-generating synthetic media that's indistinguishable. And this is mostly down to compute, which I hope is going to lead on to the next talk, right? So base computing as a measure of how good it is, 32 times more compute, you go from something that's irrelevant when it comes to the depiction of a dog to something that basically looks like a dog, right? And you can see this in all sorts of synthetic media. Now, how are we achieving this? We don't actually know yet, right? The theory behind, or the science behind why these machines are being so good so quickly is pretty poorly understood. We've got lots of engineering at this stage and not actually much science. But there are 3 ways to improve it. One is the amount of compute power, and basically more compute, the better they get. These are called scaling laws. Algorithmic efficiency, because it makes the compute that's currently available better, and then wedding or meshing these models into the ways that we actually do work, which is the last bit. And I think you're going to go through several step changes where they go from toys in 2022 to tools in 24 to basically being able to do human levels of work. So this OOM is orders of magnitude. And so we are, at the moment, we are producing AIs that can do a minute or a few minutes of work to some level of competence. But we're going through 2 and maybe 2 and a bit orders of magnitude every 4 years if nothing changes. And so in 4 years' time, you're going to be able to produce something that can do a week's worth of work, right, in an hour or a minute. And so how does this affect investing? The first thing to say is that a lot of this progress up to 2023 was all done in public. So everyone is basically doing the same thing, and startups are basically at a starting point that is as good as the state of the art. That all changed in 2023 because everything became useful and therefore worth protecting. And so I think you're probably going to get a sort of bifurcation of how well these things work. But this is last or penultimate slide. So if you think again, this is the time, right? This is your angel investing period. Like, when do you get your return? You be careful investing in companies where human level performance at 0 marginal cost will be a substituting factor. I think most companies in this space, in this time, are going to be eaten from underneath, right? You're going to have an SME that's got 1,000 people or 10,000 people, and suddenly the management team of 10 people that know the market, that know the value proposition, can do the same thing with 5 people or 10 people, like a fraction of the human capital. How's this going to stop? At the moment, it's going to stop because classical computing is going to run out of power, and probably in the 30s. And that is where quantum is going to hopefully kick in and keep it going. But the takeaway is that you should think about your investment strategy as the AI, I guess this is my thesis, AI will be solved in the 20s, maybe 30 years earlier than lots of people expected. But the amount of human capital required to go out into the market to do something is going to dramatically drop away. And so the cost of human capital is going to dramatically change. And so I guess my current company, a new one called AI8, is focusing on that. Like, we're going to have to come up with new operating systems where like 80% of the work in a company is done by a machine. And the 20% of the human capital is there managing machines. Everyone starts to become a manager of some description. Anyway, I'll stop there. Thank you.